So for Unit 7, we're going to review some important algebra concepts and kind of dip our toes into pre-calculus concepts. So this is a review, but many of you may have forgotten, what does this mean? So you have the f function, the g function, and they said find this. Well, this is the composition. So it's f composed with g of x, meaning f and g are both functions of x, and what you're going to do is put the g function inside the f function wherever you see the variable x. Another way of writing this is f of g of x, literally replacing any input in the f function with the entire g of x function. The f function is -3 times x plus 1. And now we're going to replace the x in the f function with the entire g function. X squared minus 5 minus 2x. Go ahead and distribute. Plus 15 plus 6x plus 1. Combine like terms, so -3x squared plus 6x plus 16. So when you plug in the g function into the f function for the variable x, you end up getting this. This is called composition of functions, composing functions. So putting a function inside of another function wherever you see the input. F and g are inverse functions. If and only if f of g of x reduces to be just x, and if g of f of x, the other way around, also reduces or simplifies to be just x, then f and g are inverse functions. Today we're going to verify if the given functions are inverses. Verification or proving involves every single step as part of your answer, okay? It's not just the last step, it's showing that yes, every single step, this does end up simplifying to this. So simply writing yes or no, like yes, they're inverses or no, they're not inverses, that's not enough information to prove to me that you actually are verifying if they're inverses. We will begin by plugging the g function into the f function. So f of g of x, -2 times x plus 3 cubed. The g function is this fraction right here, so -6 minus cube root 4x over 2. You cannot distribute this 2 because of this 3. This is saying the quantity is being multiplied by itself 3 times. Okay, so you cannot distribute this -2. So my next step, if I can't distribute this -2, I definitely can't apply this little 3. That only works if everything's a product. So I have this awkward fraction and this 3 inside of the parentheses. I'm going to try to combine these fractions. So that means I need a denominator of 2, so I'm going to multiply the 3 by 2 over 2. And we'll have -2 times -6 minus cube root 4x over 2 plus 3 times 2 is 6 over 2. I'm going to write that all as one big fraction. -6 minus cube root 4x plus 6, all of it is over 2. Okay, now I have a negative 6 in the numerator and a positive 6 in the numerator. We can add those to get 0. Negative 2 is being multiplied by negative cube root 4x over 2, all being cubed. Because I'm no longer adding or subtracting anything inside of the parentheses, now I can cube everything inside. So I will write the numerator. I will apply the cube to the numerator, and I will apply it to the denominator. Remember, we could not apply it at any step before because of these plus signs. So negative cube root 4x. This whole thing is being cubed, and then the 2 in the denominator is also being cubed. If you have a negative being cubed, then you end up with a negative. And then when you have a cube root being cubed, that reduces over 2 cubed, which is 8. Now you can multiply. This would be negative 2 over 1. Negative 2 over 1 times negative 4x over 8. Or you could say, 4 over 8, that's just 1/2. Positive 2x over 1 times 2 is 2. That simplifies to be just x. And so we finished the first part. All right. Now we get to do that all over again. And you have to do both of them in order to prove. Negative 6 minus cube root. I'm making this really big because I know that I'm going to have to put the whole function inside of this. But it's 4 times x, so 4 times the f function. So 2x plus, that's negative 2x plus 3 cubed. Okay, and that is all over 2. Ooh, this is a crazy looking thing. Okay, first of all, I cannot cross off this cube root and this cube until everything that's under the cube root is a product, and then I can cube root things individually. So my first step is to multiply some stuff under the root. So I'll have negative 6 minus this cube root of, it's 4 times negative 2 times this quantity being cubed. Okay, so the numbers in front we actually can multiply. We cannot distribute them, right, because this quantity is not x plus 3, it's x plus 3 cubed. So we have negative 8 times the quantity x plus 3 cubed, all over 2. At this point, I have a product. I have negative 8 times this quantity cubed. So now I can separate the cube root over those two things. Negative 6 minus cube root negative 8 times cube root quantity x plus 3 cubed, all over 2. Continue, you have negative 6 minus, what is the cube root of negative 8? That is negative 2. And that's being multiplied by the cube root of x plus 3 cubed. So cube root and a quantity being cubed, that cancels. Everything is being multiplied by x plus 3. Okay. As we continue to simplify, negative 6, I'm going to write this as a positive 2 and then distribute that. negative 6 plus 2x plus 6 over 2. Combine like terms, negative 6 plus 6 is 0. So you have 2x over 2. 2 over 2 is 1. That reduces to be x. So are these functions inverses? Yes, they are. We just proved it. So my first step is to put the g function into the f function, or the f into g. Either way, you have to do both of them, so buckle up. 2 over x plus 1. I like to leave a big space. Plus 3. And in this area, I'm going to put the entire g function. 2 over x minus 3 minus 1. Ooh, I see negative 1 plus 1. That adds to 0, so I have 2 over the fraction 2 over x minus 3, adding 3. You have 2 divided by a fraction. Remember, that could be written as 2 over 1 being multiplied by the reciprocal of the denominator. So x minus 3 quantity over 2, and then adding 3. At this point, you can reduce before multiplying. 2 over 2 is 1. So you have x minus 3 over 1, which is x minus 3, plus 3 reduces to x. Awesome. Now let's do it the other way. So I have put the f function into the g function where there was an x. In the denominator, I can combine like terms. That becomes 0. So you have 2 divided by the fraction 2 over x plus 1, subtracting 1. 2 divided by a fraction, you could write that as 2 over 1 multiplied by the reciprocal of the fraction you were once dividing. 2 over 2 is 1. And so you end up with the quantity x plus 1, subtracting 1, simplifying to x. So yes, these are also inverse functions. Ooh, don't you love the fraction and root combo? Verifying inverse functions is really just a test of, hey, can you do some possibly complicated algebraic stuff? So, can you? We have x in the numerator. So I'm going to replace that with the whole g function, which is negative 2x cubed. This negative that's in front, it could apply to the numerator, or it could apply to the denominator, just not both. So I'm going to just apply it to the numerator. Negative, negative gives me a positive. So now I just have 2x cubed in the numerator over 2. Okay, you cannot cross off these cubes until you have simplified everything inside. Meaning 2 over 2 is 1. And now you can cross off the cubes. Cube root of x cubed is simply x. Now we just have to verify it the other way. And whatever's being cubed is the f function, which is cube root negative x over 2. My first question is, can I cross off the cube root and the cube? Okay, sometimes you can, sometimes you can't. So when can you and when can't you? Well, notice that inside of these parentheses, it's all under the cube root. So if it's entirely being cube rooted and entirely being cubed, then you can cross those off. Okay, then those are effectively doing the opposite of each other. Yay! You still have negative 2 being multiplied by everything inside of here, though, after the cubes and cube roots have been crossed off. So make sure you leave that in parentheses, negative x over 2. Negative times negative is a positive, 2 over 2 is 1, and you end up with positive x. Yes, these are also inverse functions. And our last one, f of g of x. Negative x plus 3 cubed. We cannot apply the little 3 because you're subtracting 2 inside. So let's try to simplify what's inside of here. But you notice how we had a cube root. What is the inverse operation of taking a cube root? Well, it's cubing it. So if you have two functions that are inverses of one another, and one of them has a cube, the other one has to have a cube root. Otherwise, it's not the inverse function. But how could you tell by continuing to expand this? Well, I see that I can't apply this little 3, this negative 2, so maybe I should try expanding this. That's all being negative. If I expand x plus 3 times x plus 3 times x plus 3, we would have negative x squared plus 3x plus 3x is 6x plus 9, all being multiplied by x plus 3, all being subtracted, all being cubed. It's getting harder and harder for me to imagine this ends up simplifying to be just x. At this point, I'd say it doesn't look like it's getting any simpler. It just looks like it's getting more complicated. So I would say not inverse functions. If you haven't actually tried it though, and you just get to a quiz or test and you're like, I don't really feel like doing it, so I'm just gonna guess and say not inverse. Even if that's true, you're not gonna get any credit because you didn't actually show me that your guess was founded in anything, okay? Now, if you immediately look at number 4 and you say, oh, I know these are inverse because that's a cube function and that's a cube function and one of them needs to be a cube root, then you could say not inverse a cube root is the inverse of a cubic. Then I would know, okay, they can see that something is missing here and that's why it's not working out.